Okay, here we've got a question about probabilities and Sylvester the cat. But the first thing you've got to do on this question is decide on the topic. And I really don't want to tell you the answer to that. So can you pause the video and make your own decision about what topic it is, reading through carefully and taking account of what else is on the paper. Go on, decide what topic it's on. Pause the video now. Okay, I hope you've done that. If you've looked at the rest of the paper, there was another probability question. So that hints that this is a particular special kind of probability. And if we consider what we're doing, we've got a period of 14 nights and we're counting how many nights Sylvester chooses to stay outside. So we're counting the number of successors staying outside in 14 independent nights. It says it's independent. We're counting the successors in n independent trials, so we know that there's a binomial distribution going on. So we set up what x is. X has got to be the number of things we're counting. So are we counting the number of nights he chooses to stay outside or not? You may think that's obvious, that it's going to be the number of nights outside. However, sometimes you'll want to choose the number of nights he doesn't stay outside. It depends whether you like this probability, okay, or whether you don't like it. In this particular case, 0.35 is one of the tabulated probabilities in the binomial tables. So yes, x is going to be the number of nights he stays outside, but there are sometimes questions where you have to look at the opposite definition of x and work with the number of nights he stays inside and translate all the parts of the question to fit your x. So we've agreed x is going to have a binomial distribution, set up the values of n and p, and decide what range of values of x you want. So at most, be clear about whether at most means which one of these symbols it is. It's going to be one of those four. Decide what you want x to be. As you get onto more complicated ones, you'll want to list all the possibilities for x. It's up to 14 nights, so it's all the values from 0 to 14, and you need to draw a diagram showing the particular subset of values you want, which will help you find the right values to look up in the tables. Lots of people on ones like this will look up the wrong numbers. I'll give you a clue right from the start. You're not going to be looking up 10 and 5. At least one of those is wrong. So make sure you've got a reliable way of doing that. On part B, we've now got a period of 3 weeks, which is no longer 14 nights. It's a different number of nights, and it's a value of n that's not in the table. Luckily, it's an exact outcome. We want the probability that our new thing, it's not the same x as you had before, but it's exactly equal to 4, and for that you use the formula for the binomial, which is on page 11 of the formula book in the table. So ranges of values use the tables if the numbers are tabulated, but for a specific value you can use the formula. Then on part C, we're given a binomial distribution and a value of n and a value of p. So reading this far in the question could have been the clue if you'd not spotted it was a binomial distribution before. 2 easy marks here. We've got to get the mean and variance of this binomial distribution, and once again in the table on page 11 of the formula you need, page 11 of the formula book are the formulae for mean and variance of the binomial distribution, so just use them. And then, dotty 2, this is really common, after you've worked those out, we then have some sample data, a period of 13 weeks. The data collected in those 13 weeks of the number of nights per week he stayed out has this mean and this variance. And you're going to compare those with the values before. You're going to comment on whether they're the same or close or a long way away. In order for the claim, which is that this binomial distribution is appropriate, he's claiming it's a binomial with that n and that p, in which case the measured mean and variance should be pretty close to these. So either they are, in which case you're going to say we agree with Barry's claim or we think it's plausible, or there's a big discrepancy, in which we're going to say, in which case we'll say we think Barry's claim is unlikely to be true.